Good afternoon, everyone. Today we're going to solve an equation graphically. We're going to solve the equation x minus 3 being equal to x squared minus 4x plus 3. And we're going to do so by graphing the left-hand side and then graphing the right-hand side separately, okay? And once we've done that, we're going to look for where they cross. That is, we're going to look for the points of intersection between the two curves, okay? So, first off, let's call x minus 3 the left-hand side. And let's call x squared minus 4x plus 3 the right-hand side. And let's refer to them as functions, the way we typically have. So the first x minus 3, let's call that y. And then let's do the same for the right-hand side, just so we can think of them as two separate functions and graph them independently, okay? So if we go ahead and do that, the left-hand side has the function y is equal to x minus 3, which I'll remind you means 1x minus 3. Right? Now, I trust that you know how to graph linear functions. This means a line with a y-intercept at -3 and a slope of 1, right? Slope of 1 over 1. So that's easy enough to graph. We can also use a different color. We'll start with a y-intercept at -3, and then a slope of 1 means we go over 1, up 1, over 1, up 1, over 1, up 1, over 1, up 1, so on and so forth. And then we can graph, something that looks reasonably like the line y is equal to x minus 3. Now, our second equation is a quadratic equation. So we have y is equal to x squared minus 4x plus 3. We're going to graph it on the same axes and look where the two curves intersect. Now, you can graph this with a table of values if you just want to decide which x values you want to look at, plug those in to your equation, get your y values, so on and so forth. But what I've been doing with my students recently is getting the 5 important points of a quadratic function and graphing it that way. It's a bit more time efficient. So let's go and do that. First thing we look for typically is the roots or the x-intercepts, right? And those are precisely the points where we cross the x-axis, which means if we're on the x-axis, then the y is necessarily equal to 0. And so if y is equal to 0, then we can plug that into y, right? And we can solve an equation. So if we make y equal to 0, then we're really solving the equation when is 0 equal to 4x squared, we're solving the equation when is 0 equal to x squared minus 4x plus 3. And this is where factoring comes in handy. That's why it's so important to be able to factor efficiently. So to factor this equation, there's no x squared coefficient. We don't have to use decomposition. We can just think of two numbers that add to make -4 and simultaneously multiply to make +3. Those two numbers, you can think of for yourself, are x minus 3 and x minus 1, right? -3 and -1. They add to make -4 and they multiply to make +3. And so now, since 0 is equal to something times something, we know that necessarily either the first factor is equal to 0 or the second factor is equal to 0, right? That has to be that way. And so if the first factor, x minus 3 is equal to 0, then we get the solution x is equal to 3, right? And likewise, if x minus 1 is equal to 0, then we get the solution x is equal to 1. And so since at those two x values, we get y coordinate of 0, those are two coordinate points on the graph we can put. So we have the first root at x is equal to 1, y is equal to 0. That's the point 1, 0, right? And our second root is at 3 and 0, okay? And now we can put those on our graph. 1 at 1, 0, and 1 at 3, 0, okay? Now, we know that quadratics produce a graph that looks like a parabola, right? And this is a positive x squared coefficient, so it's going to be an upright parabola. When it's opening up, looks like a smile, right? So we know that those are perfectly symmetrical. And so if we have the two roots, we know the vertex, right, its minimum point is going to be right in the middle of those two roots, right, as the midpoint in the x coordinate. And so in the middle of the two roots at 1 and 3 is, of course, the value of +2. And that's going to be where we find our vertex. We could draw the line of symmetry, right? The line of symmetry is the vertical line right through the vertex of our graph to kind of show how the parabola is symmetrical about that axis, right? Just so that I don't kind of ruin the graph, I'm going to omit that line of symmetry, but hopefully that still sticks in the image you have of these functions. So the line of symmetry would be at x is equal to 2, which means the x-coordinate of our vertex has to be 2, right? We need the vertex to be right in the middle of our graph, right between the two roots, right down the line of symmetry. So we know our vertex has an x-coordinate of 2, we just don't know the y-coordinate, but that's exactly why we have an equation up here, right? So that we can relate y if we have an x. So if we know that x is equal to 2, let's plug that into this equation and solve for the corresponding y-coordinate. So if x is equal to 2, plugging that in, we get y is equal to 2 squared minus 4 times 2 plus 3, which means y is equal to 4 minus 8 plus 3, which means that y is equal to negative 1, right? So our vertex is at x is equal to 2, y is equal to negative 1, and on the graph, that is the point right here, right? That's going to be our vertex at 2, negative 1, okay? So now we have our two roots, we have our vertex, so that's 3 points on our parabola, on the quadratic function, right? The fourth one we typically go for is the y-intercept, because it's so straightforward to get. Any y-intercept is a point where we cross the y-axis, which is exactly where the x-coordinate is 0, right? And so that means that x has to be 0, and since x is equal to 0, we can plug that into, again, our equation for y, and we can get the corresponding y-coordinate pretty easily. So if x is 0, y is equal to 0 squared minus 4 times 0 plus 3, which of course is just 3. And so our y-intercept is at the point 0, 3 up here, right? And now that fifth point is typically the mirror image of the y-intercept. So you can imagine the vertex is on the line of symmetry for our parabola. And so since the y-intercept is 2 units to the left of it, right, 2 units to the left, we have the mirror image 2 units to the right of it as well. And so since it's at 0, 3 here, and it's 2 units away from the line of symmetry, from the center of our parabola, we can get it flipped onto the other side, which will be at 4, 3. And that's our fifth point typically for our parabola. And now we have 5 points nicely laid out on the graph, and so we can sketch said parabola like so. And there we are. So now we have both functions graphed on the same set of axes. We have the left-hand side, the line y is equal to x minus 3 in green. We have the right-hand side, y is equal to x squared minus 4x plus 3 in black, in this parabolic shape. And so now, to solve the equation, we're looking for the 2 points of intersection, the points where the curves cross on the graph, which you'll notice is here and here, okay? Those are our 2 points of intersection. Points of intersection. And they are at, one is at the vertex, so it's at 2 and negative 1, and the other one is at this x-intercept, which is found at 3, 0. And so those are the 2 points where the 2 curves cross, but in the name of being precise with what we're being asked to do, we're looking to solve this equation after all. And this equation makes no mention of y, right? These 2 points of intersection give us an xy pair for the coordinates of the point on a graph. There's no mention of y here, we just want the x values that solve this equation, and so we only need to consider the x coordinates of our points of intersection because, again, we're just trying to solve this equation in x, right? So our 2 solutions are going to be x is equal to 2 from this point, and x is equal to 3 from that point, and so we can write that out, x is equal to 2, or x is equal to 3. Those are our 2 and only 2 solutions. And we found that by finding the points of intersection between the 2 curves graphically. There are other ways that you can kind of check your work. If you want to get everything on one side, factor it, and then see if you get the same answers. That would be a nice way to verify your solution. But anyways, I hope this starts to make connections between all of the topics you're studying. If you guys have any questions or suggestions, please do leave a comment, and thanks for watching.